Okay, so today we're going to go ahead and talk a bit about test class moves. I want to apologize. This talk isn't quite as polished as the talks I usually like to give. I've been helping my wife launch a company, and it turns out, as some of you folks know, that's a little bit time consuming. So I've been a bit time constrained right now. Most of you folks already know who I am, Curtis Poe, better known as Ovid to most of the Perl community. I have a blog, technical blog at blogsperl.org, users Ovid, allaroundtheworld.fr. That's my wife's company, and they're actually who's sponsoring me right now. Had to talk my wife into it, so. So, for the purposes of this talk, I'm using test class Moose version 0.12. All you need to know is you need to know a little bit about testing. It helps if you know a little bit about Moose. If you know something about test class, it's really great, but it's strictly optional, absolutely not required. So, the first question I need to address is, why did I write this darn thing? A lot of people are asking about this. And it's because I got tired of emails I was getting over the years after I wrote a tutorial on test class about, well, how do I use it with Moose? And people kept asking that, and there's all sorts of reasons why it's a little bit problematic. If you're familiar with test class, if you're familiar with XUnit, you already know the philosophy behind it, XUnit testing, OO test for OO code, all sorts of little things there. So the only thing I'm really going to touch on right now is for test class Moose, one of the nice things it gives you that many of the other testing tools in Perl do not, it gives you more control over your test suite. We'll see some more about this later on, so you'll understand what's going on. It gives you a lot of fine-grained control over what you do and do not want to do with your tests. It also gives you more information about your test suite. I'll show you a little bit about reporting with test class Moose later. It's perfectly appropriate for anyone who wants to write small-scale tests, you know, just like for testing a module. But if you like test class Moose is really good. If you have a large test suite that is beginning to be unwieldy and difficult to manage, test class Moose is a really good option for you, with the caveat that right now it's in beta. So keep that in mind. Oh, and I forgot to mention, so test class plus Moose, a lot of people also like test routine and test roux. Test roux works with Moo. Test routine is, well, testing with Moose. A lot of people like that. Check those out too. They have a different philosophy about how to do testing, but they're alternatives to this. So I'm not going to cover this right now, but if you're curious about really how to use test class in depth, it's a bit out of date, but on Modern Perl books, this presentation I'm going to put up on SlideShare in /Ovid, so you'll have it soon. I've got a 5-part tutorial on test class and how to use it, and really digs down deep into a lot of what's going on, and you'll understand at the end of that tutorial a lot of the things which I'm just going to gloss over right now, such as this base class. This is a sort of base class you often write with test class, and I'm not going to go into the details as to what all of this stuff does, but it's always been very frustrating to me because mine usually looks like this, and I don't want those items that I've just crossed out there, because to me those are code smells. Those are signs that there's something wrong with the test suite, there's something wrong with how I've designed things. So with test class Moose, that stuff goes away. I don't want to have it. This is what a base class, a standard base class in test class Moose now looks like. A lot of the extra cruft that you put in there doesn't exist. You use test class Moose, that automatically sets up your inheritance and some importing. Why you do it that way instead of use parent or use base, long story I won't go into. And here's a role. With test class Moose role auto use, we'll see this role a bit more in a moment. I won't go into it now, but as you see right away, we've got Moose, we've got roles. And this is what our driver looks like. For our test class, when you're using test class, a lot of people like to have one driver per test class. I recommend one driver for your test suite. Again, I won't go into why, but this is what the driver looks like with test class Moose. You put in a t/test.t. Test class does test class run tests, runs all your tests, that's it. You have no control. There's nothing else you get. Test class Moose gives you a constructor. I won't explain what all of these things do, but you can get an idea what some of them do. They give you a lot more information, a lot more control over what's going on with your test suite. That test class is argv. You'll see that in just a moment. And after you've instantiated an instance of your test class object, you then call test suite run tests. And down here, there's this report thing, which some of you might find interesting. Again, that's really nice for larger test suites. So let's just see basically how this works. We have a very simple Moose class We're skipping some things here, such as namespace, auto-clean, package, meta, make immutable, because I just want to focus on the code that you're actually concerned about. Simple person object, we have a first name, we have a last name, and we have a method, which just returns first name, last name, joined by a string. Nothing fancy, nothing difficult. And too much code on the slides, I apologize for that, but there's a lot of stuff to cover here. This is a basic test class. So package tests for : person, use test class moose, then you specify that your parent is that my test class auto use that you had. And then sub test underscore constructor. That's the first important thing to think about. With test class moose, we don't have to use attributes. By default, any method which begins with test underscore is a test method. If you don't want it to be a test method, do not begin it with test underscore. If you need a helper method for your test class, call it anything you want, just don't begin it with test underscore, and that's fine. So test underscore is reserved. If it begins with test underscore, it is a test method, and that will automatically be assumed to contain tests. And every method gets two objects. Think of $test as $self. I, as an affordance, like to call it $tests in my test, just to make it crystal clear in my mind all the time that I have a different mindset for how I test. We have a report object as the second argument of every test method. So it's always the invocant and then the report object. Those are your arguments for everything, period, end of sentence. So it makes it very easy to read. And then this is the curious bit. First of all, if you're colorblind, I apologize, but the code which is in red, you'll notice tests for : and over here we have auto use. What's going on with that? You don't have to use this. A lot of people think it's a little bit too magical, but I find it very handy. Notice we didn't actually use our person class. You don't have to with this. Down here on this line, which says, is it okay, blah, 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 test class underscore name. If you use the auto use role, you automatically use the class that you're testing. It just strips off the first component of the package name, and then it provides a class in class underscore name. If it can't use the class, it'll die, and this class will be skipped, and you'll get an error. And I have deliberately hard-coded the class name in my person equals person new, and you'll see why. And that's because of a very, very common failing in test class, which not in the test class, but in how people use it, which we're going to see in a moment. And batteries included. Is it okay and is? Where do we get those? Test class moose is actually a combination of test class moose and test most. So you don't have to write this anymore. All that stuff, all the most popular testing functions, and I determine those by running heuristics over the entire CPAN to find out which test modules people were actually using. So you don't have to worry about those anymore. They're just included for you, all your most common testing functions. Forget all the boilerplate, just start writing code. And then if you remember the driver I told you about in your T script, we create a new test class moose object, and test classes / we're taking a reference to argv run tests. What does that actually do? So test class moose new blah blah blah. It lets you do this. prove-lvt/test.t : tests for person. That will only run that test class or those test classes that you provide after the double colon. And for historical reasons, that double colon is called the Aristotle, after the man who named it. So this allows you, when you're writing test classes, to run tests for a single class. If you don't want to run your entire test suite, if your test suite takes 20 minutes to run, that can be very frustrating. So this is a nice shortcut for you. If you are familiar with test class, this functionality is often simulated by putting your test class run tests in an init block in your base class. That's one of the many things you don't have to do anymore. So it's some cruft which has gone away. And it spits out nested tap. It doesn't spit it out colored like this. I've just colored it so you can see what goes where. Now, if we actually go back to the driver script, you'll notice the statistics is 1. You pass it a true value at the end of your test class moose run. You'll see the number of test classes that were run, the number of test methods that were run, and inside the test methods, those are subtests. It'll tell you how many of those tests which were run. Generally speaking, when you use subtests in your code, it'll be reported as a single test. Here, we actually count the number of tests run inside of the subtest. So you can actually figure out how many tests total, if you think that's important, were actually run. If you use subtests within your test methods, that doesn't hold true. So plans. How do the plans work? You may have noticed, if you notice that in the test code, I didn't have a plan asserted anywhere. When test class Moose loads, it sees this is how many test classes I am going to execute. So in this case, we had 1, so we have a plan of 1. Inside of our top-level subtests, on our test for person class, we had 1 test method. So again, we assert a plan of 1. And inside the test underscore constructor test method, well, we ran 2 tests, and here we just use a trailing plan. We use done testing by default. That's a default behavior of subtest. So if you do not want to, you do not have to specify plans anywhere at all for any reason whatsoever. Test underscore some name, bam, test method. But if you want a plan, you got it. So I mentioned the second argument to every test method is your report object. The reason why this is separated from the test object is we try to minimize pollution in the test namespace because you're inheriting from this. So a lot of your extra stuff goes on your second object, your report object, and you say report plan 2, and we know that we have 2 methods that are going to be run there. When you run your test suite, your plan will still be reported at the bottom of test method. That's more or less because of, I won't get into all the details, but you can have like an after modifier or a before modifier, which also adds to the plan, so you don't know exactly when the plan will be declared. So it always has to be done at the end. So you could report it at the end of this, it doesn't matter. It's just for this plan, for your subclasses, which might override this method and call the super method, or for any method modifier, such as around, before, and after, you can keep adding on to that plan, and at the end, it'll assert the correct number, and if you have the wrong number of tests, it will fail as you expect. Before we get to subclassing, I know I've covered a fair amount in a very short period of time. I've talked too fast. Does anyone have any questions so far? No?
I have a, this might be a stupid question. I apologize in advance.
Nope.
If you're not using Moose, if you just have other, like, procedural, just other object-oriented code, do you still get benefit from using this?
Yes, you, particularly again, if you have a larger test suite, you will get tremendous benefit, potential benefit from the control you'll have over the test suite and the reporting you get in the test suite. And that's covered a little bit more in the second half of this talk, where I get a little bit more in depth about some of what's actually going on with test class Moose and what sets it apart from actual test class. At this point, there is nothing you have seen which is really that different from test class or my test class most module, which bundles all the common testing functions in there. Most of this is fairly straightforward so far. Any other questions before I go on? Yes?
Maybe just to clarify on that, so the word class in the name of this package is referring to the fact that the tests themselves are classes, not what you're testing.
What you're testing doesn't have to be a class. If you like XUnit style testing, this is perfectly appropriate for you. I'm primarily showing the way in which we model a test class and the classes they test in a one-to-one relationship. This is why the auto-use role that I provide is very, very handy. If you do not like to do that, there are many other ways of doing that. It's OO code, and any tricks that you can think of with the OO code for how you want to model things, you can do it yourself. I just have that little helper in there, auto-use, which does allow you to test a class very easily. It would allow you to test packages very easily, but I think of it more as a class-based thing. But no, you do not have to test just classes with it. Any other questions? Okay, this will be the last question before I move on. Yes?
Yeah, I've actually started using test class, and
Woohoo!
yeah, and the one thing I was that stuck out to me initially was that we didn't really want our tests to run fast, usually, and so I was wondering why you chose to implement it with Moose as opposed to Moose or your own object.
So what he's asking is you generally want your tests to run fast, so why did I choose to implement it with Moose instead of Moo? There's a few things going on. First of all, Moose is far more mature than Moo. Moo's a great module. With tests, I would much, much rather prefer that my tests be absolutely correct than fast. And Moo does allow a bit of sloppiness here and there, which for the most part is fine. But I'm also used to running tests on extremely large-scale test suites, sometimes up to 500,000 lines of code. I have test suites which take over an hour to run, and that gets to be extremely frustrating. So my experience of the primary problems you have with test suite performance, they are almost invariably something happening down at the database layer for most of the test suites that I work with, or you have some sort of network issue, you're contacting a remote, say, CouchDB server or something like that. All sorts of things external to the actual code in the test suite causing performance issues. Once those are handled, the third most important thing that I find causing test suites to run slowly is the fact that tests run in different processes. And because we have separate test programs, not because we're forking off a lot of processes. So what actually happens is, if it takes 5 seconds to load up your Catalyst, your Moose, your DBIX class, and you have 10 T scripts, that's an extra 50 seconds just for those 10 scripts. If you have test class Moose or test class or anything similar to that, test aggregate, which runs everything in a single process and loads everything all at once, you take the 5-second hit one time, and then at that point, any errors with shared state at that point start becoming more of an issue, which is something some people need to think about. But that is so Moose generally is not the bottleneck that I find. I do have occasions where that's been the case, but that's usually when I'm dealing with code where I have to worry about millisecond response times. I have to do that from time to time, and Moose often is not appropriate there. That is the exception and not the rule. So, thank you. So, part 2. We'll start with subclassing. We have a very simple class here, person employee. Now, you remember the person class had a first name and last name attributes and a full name method. Person employee, all we do, we extend person, and we have an employee number attribute. There's nothing fancy there. So let's write a subclass for that. If you have a package which inherits, if you have a class which inherits from another class, your test class should inherit from that other corresponding test class. It's a very important concept to keep in mind, and I've made my test really stupid here so you can see exactly why this is the case. So we have package tests for person employee. Now extends tests for person, and you may recall the test for person extends, my test class auto use. So we've auto used person employee already here. And then I didn't write any tests at all. Hey, I have tests in my test suite. Even though I'm doing prove t/test : test for person employee, I still get tests. And if you look at this, you'll notice running tests for person employee, even though I didn't have any, that's because I inherit my test for test constructor, because those were in tests for person. What inheriting tests does is, if I do not change the behavior of something, the tests for the parent class should pass for the subclass. If you're confused on what's going on, I recommend you look up something called the Liskov substitution principle. The idea is you drop in a subclass in the same place as your parent class, your code should still generally run correctly. The reverse is not true. So if you do not override a test from your parent class, you will inherit that test and you will run that test. So test for person employee, we have test underscore constructor, and we failed our very first test, which is the object from the constructor is a person employee. No, it's not. It's a person. Because you might remember, we deliberately hard-coded the person name right there. So, but we had the isOK person test class name. So the question at this point is, how do we fix this problem? And I see this a lot of times when I work with test class test suites, that hard-coded class names are all over the place in a very inappropriate fashion. So our test for person employee, we could override the test constructor test, but we don't actually want to do that because that behavior more or less shouldn't change. Why should I have to rewrite that code? I don't want to maybe we don't inherit for tests for person. I want to inherit the tests that test for person has. As you extend person, those tests will automatically pass for tests for person employee too, assuming you haven't broken anything. So what we actually do is we want to instantiate our object correctly. This is one method of solving the problem. I am not saying this is the only way of solving the problem, but it is one method. And in this case, we're going to stop and recap before I show you the solution I've used for this talk. We've written 2 classes. We've written 2 test classes. We've seen test inheritance, but it broke our test. So the key is you need to separate your data in your code. Many, many different ways of doing this. In this particular case, you'll notice I have a method called constructor_args. Because that does not begin with test underscore, test class moose is going to ignore it. So it's perfectly safe. And then down here, okay, my person equals test class name new test constructor args. So I've now constructed a new object. By the way, note the plan here is 3. I decided to just add an extra test so you can get used to seeing how plans work. And then in test for person employee, around constructor args, return self orig report employee number. I just add an extra argument because the employee number is required. So I want to make sure this extra argument gets passed to the constructor. And for test constructor, well, it's still not quite where we want it to be. We have test next method report. That calls your superclass. Great, that works fine. All those tests are going to pass. And then we have a test class name new. We call it again just so we can test our employee number is correct. So, and also if you look at it, it asserted the plan for this block of code is 1, which means the previous one was 3, this one's 1, so we now have 4 tests. So now our tests are passing, but it's still a little bit ugly because we've had to instantiate this object twice. So I don't like to do that, and little bits of cruft like this can easily get into a test suite. Some of this may seem to be a little bit complicated. A lot of this is simply getting used to this and building these patterns into your brain of how to avoid common problems you have with XUnit style testing. Before I show how to solve that, I'm going to talk about our test control methods. This is very popular in the XUnit world. And it's part of the reason why isolating tests, in regular Perl tests, .t tests, a lot of the behavior we isolate simply by having them in separate files. Whereas the test control methods for startup, setup, shutdown, and teardown, these give you effectively a lot of this isolation by allowing you to control what happens at the start of every test class, or what happens at the start of every test method, or the end of every test method, or the end of every test class. And these methods, test underscore, startup, setup, teardown, shutdown, these ones, by the way, do not allow tests to be run in them. You'll get an exception if you do. There's no point in running tests in your test control methods because they're not there for tests. They're for setting up your tests or for setting up your test class. So run your tests in your test methods. So why do we actually use these? We use these for all sorts of things. We might want to, maybe we want to connect to a database. Maybe we want to set up some fixtures for a particular test method. We want to roll back a transaction, start a transaction. Anything you can think of, which is something that the test will need without necessarily being the test itself. So in this case, we're going to use a setup method. Now notice we have this attribute, test underscore person. I showed you that just to make one thing clear. Test class moose cares about methods beginning with test underscore. It doesn't care about attributes beginning with test underscore. So in this case, we have an attribute called test person. Test class moose knows nothing about it because it's an attribute. It doesn't care. And then in our test setup method, remember, test setup is run before each and every test method. This is a case where going back reading my test class tutorial will really help you a lot, understanding how to use test control methods. Test setup is run before every test method. And what we do is we always call our next method in test setup to make sure we call our parent setup. I should have passed the report object there. I forgot. Sorry, that was a little bug in my code. And then we set our test person attribute to be the object that we've created. Test constructor looks like normal. And then in our subclass, we don't have to construct the object again because it's stored in our test attribute in this subclass. Does that make sense so far? Cool. And when you run the test, exact same behavior as before, but you don't have the duplicated behavior of having to instantiate the object again just to test that one little attribute, because you don't want to do that. And if you run the entire test suite at this point, in other words, you don't pass it the Aristotle and the class name, just prove-lt tests, we see how many test classes have been run. At this point, because running the entire test suite, why do we have 3 test classes? Because it's also counting the base class. Test methods, we have 2. We have So, okay, well, we have a test method for test for employee, we have a test method for a test for a person employee, and then the total number of tests run and all the test methods, 7, all tests successful, looks just like normal. If you don't like this extra information spit out, then just don't pass a true value to the statistics argument in the constructor. At this point, you have seen virtually everything you would be able to do in test class. So for that style of testing, all of it is perfectly normal. There's nothing fancy. This is where things start to get a little bit interesting, and when you have larger scale test suites, it's very handy. We can tag things. Now, test class uses attributes to specify that, this is a test method, here's how many tests we run, or it's a test control method. We don't do that here. Tags, in this case, are anything you want them to be. They're little strings of data that you can attach to a test method. They don't impact test control methods. You can put them there. They're a no-op. And you can say, okay, this has something to do with a network. What do you do with that? Well, in your driver class, if you want to, you can say, I just want to run all my tests which touch the network. A couple of months ago, I was at our offices in Paris, and we have a company nearby building a new business, and they keep cutting through our cable, our network cable, and we lose our network connection. And a lot of my tests were touching Redis and things like that, and not locally. They had to connect remotely for various reasons, and my test suite would get shut down. I really wanted to have this feature so I could say exclude tags network, which would allow me to run my entire test suite, but I don't want to touch any of my network tests. And it would have made my life so much simpler. And when you run the test suite, only that test underscore something method, the one which had the network tag, gets run. Everything else is excluded, and you can put multiple tags in there, such as network or unit. And that's rather interesting, because sometimes, like code coverage, one thing I hate about code coverage is, great, I've got 95% code coverage on everything, and then after a while you find this code which has 100% code coverage, but it turns out it's dead code. So why is it covered? Because we wrote unit tests for it. So instead, I might want to do something like tag something as, say, API. Only my API tests should be considered for code coverage. Or maybe I want to exclude all of my unit tests when I compute code coverage so I can get a better idea of what code I'm really exercising. And then, running this little thing in verbose mode, we can see things like we're skipping various tests because we didn't find test methods which happen to meet the various tags that we were asking for at this point. So for tags, all sorts of things. If you only want to run your API tests, maybe you only want to run your unit tests, run your database tests, etc. This planned bit of creating fixtures only if the test needs it. Right now this actually works, but I need to think of a better API for it, so I haven't documented it. So for a test setup method, if you need to connect to the database and do a whole bunch of heavy work, and 7 out of your 10 test methods don't actually need to connect to the database, then you could skip the fixture work just for those. And again, the example I used was skip network tests if the network is down. You can do that if you start attaching metadata to your test suite. So this is more or less what's going on with the tags. This was actually built into, this was an add-on to test class. No one actually used it because so few people were using test class, unfortunately. They never saw this add-on. Mark Morgan built this. Thank you, Mark. So that's 30 minutes. Great, we're doing fine. Any questions so far? Yes?
Sorry, did you say that you could tag certain things within the setup such that if you're skipping certain tests, that it skips the portions of the setup that you don't need?
This is a planned feature which I have now, but I haven't exposed it because I want to make sure I expose it with the correct API so it's easy to use. The idea being if tagging only works more or less for test methods. It doesn't work for the test control methods. You can do it, but it's a no-op. Tagging also doesn't work if you don't have sub-attributes installed. There's some problems with how attributes actually work, and this is an XS module which is necessary in order to make these tags work. If you don't have this XS module installed, then requesting to include or exclude tags is simply a no-op. And it'll throw warnings, but it won't actually impact your test suite. But you can basically, you can assign metadata via tags to your various test methods, so you can have more information about them. You can, later on, when I start integrating tags better in the reporting system, you can say, give me all the statistics for my database tests, give me all the statistics for my API tests, give me all the statistics for my unit tests. So just an include or exclude test it any way you want to. So slice and dice your test suite as fine-grained as you care to do so based upon how you decide to attach metadata to them. Does that make sense?
Yes. So slightly different question altogether. If you wanted to, for example, in a continuous integration environment, you wanted to run a battery of tests that only the quick tests, because at this point you just want to find out if it's probably going to work. You're going to do your detailed test later on. Is there some way to control which tags are ignored or excluded or included from the command line or from your environment variables, or do you just not adjust that right now?
Because this is just standard OO code, anything you can do with OO code, you can do from the command line or with environment variables any way you want to via the driver script that you have. For something like that, what you could do is use the reporting, which I'm about to explain, so that every time you run your continuous integration, I would be concerned about only running it for quick tests, but this is your choice. You could use your reporting to say, tell me which of my test classes or test methods exceed X amount of time. One thing I haven't shown, for example, is you can exclude individual test methods if you so desire. I won't get into that right now. So what you could do is every time you run your test suite, you can say, okay, I'm going to do my reporting. Tell me all the test classes and test methods which take more than 1 minute per test class, for example. Save all the ones which take less than a minute. Next time you come along, read the ones which take less than a minute. Actually, no, you would want to exclude the test classes which take more than so much time. That way, if new test classes are added in the future, those get run by default, and then you could check and see, oh, they take more than X amount of time. I will exclude them from my test run. Again, you can do the same thing with test methods at an individual level via an include, exclude, regular expressions, which I did not cover here. So the tools are there. I just try to make generic tools which will supply a variety of needs without necessarily trying to guess too much about what people wanted. Does that answer your question?
Yes.
Okay. So the reporting, which I happen to allude to many times there. I'm not going to go into too much detail. This is still being built. Everything you see in this presentation works right now, by the way. It works just fine. So you can run test class moose new, run tests, and then get your test report object back. This is because I always just return the invocant for everything until we get down to test report. And you can ask all sorts of test questions with your reporting if you want to. And this is the example that I happen to use in the slides. You can even turn your test report into another test. So what you do in this case, you instantiate your test suite object, and then you run that in a subtest. So this requires that you have a test more greater than, I don't remember the number, 0.88? I can't recall. And then, subtest, full test suite, you run it there, and then my report, you get your test suite object. And then if you wanted to, this is all documented in the code, not documented as well as it could be. You can just get all your test classes. You can assert that none of your classes were skipped, which would probably break your case. You then, for that class, you can get all your test methods. You can get the method name. You can assert that the method's not skipped, num tests, whatever. We have some tests run. Down here, we get a time object. And we can just say, oh, here's how long this test class took to run. Now, for the reason why some of this is so important is when you have a huge test suite, hundreds of different test classes, thousands of different test classes, and this test suite is taking an hour to run, it can be very hard to know that it's only 5% of those test classes which are taking up the majority of your time, unless you're really paying attention. If it was only 5%, you would know. But it can be hard to know which ones are slow, which ones are really causing the problems. This way you can find out exactly what is causing the problem at any time. And the report objects that I happened to mention earlier, these all implement a reporting role. This is because these objects are slightly different for the class and the method level. And they have the name of what we're reporting on, the class or the method. Notes, that's just a hash ref, and it's for you. Anything you want in the notes object, you can just store in the notes object. So when you finish running your test suite, all the notes are there. And you can then say, oh, this test method happened to store some notes in there, read out the notes, print them out in your test report. You can skip anything which takes a report object. If you pass it a string for skipped, it will assume that it is skipped. and it will report that reason as why it's skipped, and then is skipped will report true afterwards. And then you've got a time object. And this is just a test class moose report time. It's got real time, user time, system time, and then if you like, you've got a human readable duration available for you, so you can find out, you know, what's really going on. You know, maybe it's using a lot of CPU time, or maybe there's something else hogging the CPU time while you're running the test suite, and the, you know, the system time really isn't matching your real time. You can dig in, try and figure out what's going on. So those are the sort of tools that are available currently for you in the reporting stuff. There's more I'm planning on adding later. I'm actually thinking about writing a test class compatibility layer so that you can minimize the hurdle if you're trying to convert from test class to test class moose, but I have not done that yet. And basically what we have fine-grained control over our test suite, primarily via the tagging mechanism, which says we can run or include or exclude these test classes. We can also include or exclude test methods based upon regular expressions. I didn't show you that here. We have XUnit style testing for those of you who really like to have that sort of setup. You have full Moose integration. If it's available in Moose, it is now available in your test suite. And we have reporting available for you. So anything you want to do with your test suite, any way you want to slice it, dice it, any way you want that control, it is available for you. Buy my books. My wife told me to do that. Any questions? Yes?
So you have prefixes for methods in namespace, test underscore.
Mm-hmm.
Right? Those same prefixes are also for the control functions and some reporting function, it looks like.
Okay.
That's a bit confusing.
Basically, for the reporting, that's all in different classes. Entirely different classes. So they do not touch the test class moose tree at all. Anything that you have which inherits, I'm sorry, he was saying it might be a bit confusing because various different things have test underscore as a prefix for test methods and also in the reporting functions. Yes, that could be, but just keep in mind the reporting, completely separate. I keep all of this information stored off to the side and not directly within the test class moose objects because I wanted to minimize the namespace pollution. So in test class moose, aside from test underscore, your namespace pollution is you have the new constructor. You also have an import method, which is kind of a hack in order to allow you to inherit and also export a lot of test functions at the same time. There's something called MooseX exporter, which I didn't play around with at the time because I was trying to minimize some of my dependencies. I might go back and revisit that at some point in the future. But yeah, so test underscore, this is just your test classes. And yes, you do have the test control methods, as you pointed out, the test startup, test setup, test teardown, test shutdown. Yes. That might be a little bit confusing, but I wanted to just keep, I felt it was better to keep, originally I called them setup, shutdown, teardown, etc. But I decided if someone's testing a setup method in their code, they might want to call their test method test underscore, or they might want to, oh, yeah. Okay, so that is something I should maybe think about. Thank you. But yes, anything test underscore, thank you. Reserved. Just assume that if you are not using it for something directly related to test class moose, just don't use the test underscore prefix. Everything else is available to you, except the import method. Okay, anything else? Yes?
So back to the performance when you're testing moose classes. I've noticed it in my testing now that...
I'm sorry, I've got lights in my eyes. I can't see who's speaking.
Oh, very good.
Ah, thank you.
So every .t file, in my case, probably loads some moose file, so you get that startup every time you load a test case. And what you're saying is that because we do one process, we gave the moose startup off once.
Yes.
But I'm wondering, let's say I ported my test suite to use test class moose, there could probably be some side effects because there could be static class members, not that that's a good thing, but that's maybe getting incremented, right? And things could change depending if you're doing it in one process or a fresh new process or all in the same process.
Yes. This is something people debate about quite a bit. It's a little bit controversial. I found when you do switch over to something like this, you actually wind up with two classes. I'm sorry, he was asking about the issue where if you decide to convert everything from separate t-tests to, a single test for a test class moose and a single process, yes, you get rid of the load over time, but you might have side effects from everything running in a single process. you wind up with two classes of errors in there, generally. One of those is errors I find coming from the test suite, say, failing to clean up after itself properly. And that's just a bit of sloppiness. You always want your test suite to clean up properly, disconnect statement handles properly, or whatever. The other error, and this is the one that I want to know about, is when I have some sort of global state that my system is not managing correctly. Because, at least for the kind of software that I write, the global state that I have in my code is I'm running it in persistent code on some sort of server out there. So if I have all of these different modules and they are not managing their state appropriately, that's something which separate t-tests will never tell you, because you won't see the spillover between them. When you run everything in a single process, if the different modules aren't managing their state appropriately and you wind up with strange side effects, and that's when you wind up having these weird intermittent bugs. Sometimes when you wind up having weird intermittent bugs in your test suite, you can say, oh, that's really interesting. And then you can start digging in, trying to find out what's going on. So yes, you do have this happen. When you first make the conversion, it's been my experience from doing this many times, it's a nightmare at first. Because it is the tests just not cleaning up after themselves, programmers just saying, oh, everything's just going to close automatically at the end of the scope run, which means you have to then go in and clean it up afterwards. I find the test control methods of test teardown and test shutdown are often very handy places to do this, and if you have a well thought out inheritance system, you can often do a lot of that automatically for you. Just do it once or twice, it'll catch the bulk of those issues, and then you wind up with the inappropriate shared state issue in your actual code that you need to deal with. So I don't find it to be a problem after I get this running. If, however, you start from ground up with test class moves and you never started with t-tests, this won't be an issue. The only time the bugs will show up generally is when they're real bugs in your production code. My experience. I'm not saying that works for everyone. Yes?
Is there support for parallelized test running?
So someone asked me about that the other day. They were talking about integrating this into Fennec. And it is important, first of all, to remember, I deliberately chose to use a very normal, ordinary paradigm of test classes and test inheritance because we know how that works. We understand how it works. If there is a way you can get your objects to run in parallel, you can get your test classes to run in parallel. So what I suggest, if you have something like that, is you can override your untest method if you wanted to. You can then tag all the tests which can run in parallel as parallelizable, or maybe something which is a little bit less of a tongue twister. I'm glad I wasn't drinking before I said that. But I'll be drinking after. Sorry. So the plan is I have the tools there to allow this to happen. So you tag everything as I can parallelize this, or must be run independently, or however you want to tag it, so that when you override your run test method, it then knows which tests can and cannot be run together. When you do that, this is when your test reporting actually will start come in handy, because you want to start tracking the state of your tests over time. If these particular tests take a huge amount of time, well, maybe you want to spread those particular tests across several different threads or several different processes, rather than have all of them in one process and then all your fast tests in another process, and then it doesn't get you much good. But because now you have the method, the test class test reporting, you can then find out which tests are fast, which tests are slow, so you can do a better job of scheduling your parallel tests. Does that answer your question? Yeah, okay. So tag your tests appropriately. You would override run tests, and I would then recommend afterwards, again, capturing the information from the report to find out which of your tests are slow, so you can start writing an appropriate schedule for them.
It would just be nice to have another module or something that manages the little thread pool and sends off the tests and collects the reports.
If anything, I would do that with like a parallel fork manager or something like that. Threads in Perl are, a steaming pile of ones and zeros.
Yeah, when I say thread, I actually mean process.
Okay. Yeah, if someone wants to tackle parallel fork manager, I would love to do it myself, but like I said, I'm starting a company with my wife right now, and My bandwidth is not what it should be. Yes, anyone else? Yes?
Could you discuss again, so there's something like an adapter or a harness that kind of scans or otherwise finds your test classes and runs them, and then can report on those? How does that work? I'm sorry. So you have t/tests.t.
Yes.
And then the individual test classes are also asterisk.t files, or they're PM files?
They are .pm files, like tlib tests for, /person.pm. You keep them I generally like to keep them in a separate path, because if you put them in your lib directory, there's a very good chance they're going to get installed with the rest of your code.
Okay.
Some people actually like this.
So test.t scans for those PM files that are within the test.
Oh, I'm sorry, I should have made this clear. You see at the top of this, use test class moose load, and then you pass it one or more directories saying, I knew that. Hello? Okay, I think maybe it's not going to come back, which is a little bit disappointing. So basically, what I had at the top of the driver test, that's a little frustrating, is use test class moose load, and then the import list, you can pass it one or more directories and saying my test classes live here. And then it automatically goes through, finds all your test classes, and loads them for you. The old way people used to do, use this test class, use that test class, use the other test class, and I would go in and I would check those test suites, and I'd find out that they forgot to load a particular test class, and they weren't running the test for it. And they were long broken. So I wrote test class load, which is now test class moose load for the purposes of this module, to automatically find and load everything for you.
I understand the topic of this is all about using this test class moose, but have you thought about allowing for alien tests that it kind of runs the old asterisk.t, the non-moose way? It collects the tap output, but then it provides the statistics and other kinds of things so that you can incorporate your tests that you haven't converted yet with the tests that you have converted?
No, I had not thought about that. Possibly, it's something I could give it a thought to, but I think I might want a separate driver because the test class moose base class does a lot of things under the hood, just to track the state of everything. And because everything's run in a single process, and the .t test will not be run in a single process, the test class moose base class code potentially won't have access to that. So I don't know, something to think about. I'm not sure offhand how I would implement something like that. Am I out of time? Okay. Thank you very much. Hope it was useful.